So what is the equivalence principle? The equivalence principle is saying that the movement of an object inside the gravitational field is not affected by the innate property of the object itself, for example, the mass and spin. This was first realized by Galileo Galilei in 1500s, where he experimentally showed two iron balls with different mass will fall on the ground at the same time, followed by the same trajectory. The mathematical statement was further established by Sir Isaac Newton using his second law of motion. However, in Newton's case, the equivalence between the inertial mass and the gravitational mass is put there by hand. It means we cannot derive the equivalence principle from Newton's law. We have to demand it as an input. It was not until 300 years later Albert Einstein incorporated the idea of special relativity with Newton's equivalence principle and concluded that gravity is really an effect of space-time geometry. Namely, the movement of an object inside the gravitational field is only dictated by the local space-time curvature. In the theory of general relativity, this Einstein theory, equivalence principle is really an emergent phenomenon, namely that we can derive equivalence principle from a deeper principle. In this case, the deeper principle is that gravity is really an effect of space-time geometry.